Hello there, paleo people. On today's podcast, we'll be taking a dive back into the depths of the Devonian and look at the bite of the famous bus-sized marine monster Dunkleosteus. In February of 2007, Philip S.L. Anderson at the University of Illinois and Mark W. Westneat at the University of Chicago teamed up to write the paper Feeding Mechanics and Bite Force Modeling of the Skull of Dunkleosteus torelli, an Ancient Apex Predator, that was originally published in the Royal Proceedings Biology Letters. Dunkleosteus was a genus of Arthrodire placoderm, arthrodire being Greek for jointed neck and placoderm indicating a hard dermal armor on the head and thorax, with the rest of the body being soft tissue. In their paper, Anderson and Westneat analyzed the biting mechanics of Dunkleosteus in order to characterize the early evolutionary history of vertebrate feeding. The function and structure of placoderm skulls, as they are an earlier sister group to jawed vertebrates, aid in understanding suction feeding and jaw mechanics of other organisms like sharks and alligators today. Now there are some methods behind the madness that is Dunkleosteus' shearing chomp. Dunkleosteus was a fearsome beast without teeth, but rather two sets of bony bladed jaw plates that sheared prey into pieces. Essentially, placoderm's biting mechanism is a 4-bar linkage mode consisting of the skull, thoracic shield, jaw depressor muscle, and lower jaw, all joined by connective joints, with the thoracic shield functioning as a fixed link in the system. In their experiment, Anderson and Westneat used 5 different specimens at the Cleveland Museum of Natural History. First, they created muscle casts to fit into the muscle cavities. The team then developed a biomechanical computer model to simulate skull motion and bite forces by shortening the cranial muscles to different lengths. What they found was that placoderm skulls can be modeled by this 4-bar linkage mechanism. Furthermore, the craniothoracic articulation only present in placoderms is what's responsible for the high speeds and incredible bite forces produced in these models. 50 milliseconds to open and close, and over 5,000 newtons in force. Previous research on Dunkleosteus suggested it to have a slow but powerful jaw system, but au contraire, this study shows an average KT, kinematic transmission coefficient, of 3, meaning that the lower jaw drops 3 times faster than the cranial rotation that drives it. Instead of being a large, lethargic, but powerful giant, the high KT values for Dunkleosteus suggest that it was an instantaneous and quick feeder, with bite speeds and forces greatly surpassing those for all other fish species and many modern mammalian predators. Anderson and Westneat's slam dunk of a paper sets Dunkleosteus up to be the apex predator to end all other apex predators. As Anderson puts it, the combination of power and speed seen in Dunkleosteus would have allowed it to consume virtually all other aquatic species in the fauna, making it one of the first true apex predators seen in the vertebrate fossil record. Well, my paleo people, that brings this jaw of a podcast to a close. Tune in later in the week for our crucial discussion about which arthrodire placoderm is the cutest. Thanks, folks. Paleo on.